Alright, in this video we are going to be looking at the quotient of powers property, and quotient means we're dividing and powers means that we have exponents. So just to make a quick example here of what we end up doing, let's say we have x to the 6th, y to the 4th all over x squared y cubed, like this. Well, with the quotient of powers property, we actually end up subtracting the exponents. So 6 minus 2 is 4 for the x, so x to the 4th, and 4 minus 3 is 1, so y to the first power. We don't have to write the first power, but that is actually what you end up doing. Another way to look at it is we look at the top and the bottom, so we just look at the x's first. So the x's, the top wins by 4, because it's got a 6 on top and 2 on bottom, it wins by 4. So it stays basically on the top. And when I say that, I mean we could always list this over 1, like that. You can look at the y the same way. So the top has 4, the bottom has 3, the top wins by 1. So let's do another quick made-up example here. So let's just basically switch this around. So x squared y cubed, if we started with that on top and we had our x to the 6th, y to the 4th on the bottom. So let's just switch that around. Another problem. So we're going to apply this. We're going to subtract. 2 minus 6 is negative 4, so we would have x to the negative 4 power. And for the y's, we're subtracting the exponent, so 3 minus 4 is negative 1, so y to the negative 1. Now the problem is we have these negative exponents, so then we have to move them to the denominator, both of them. So we need a 1 as a placeholder on top. Bring the x to the bottom, make its exponent positive. Bring the y to the bottom, make its exponent positive. So that's where we end. It's a little bit faster, and most students like to say, well, who wins and by how many? So for the x, the bottom wins by 4. We have 6 on bottom, 2 on top, so the bottom wins by 4. So we know we're going to have x to the 4th on the bottom. And then for the y, well, the bottom wins by 1. We have 4 on bottom, 3 on top, so the bottom wins by 1. So we have y to the first power. We don't have to write the first power. And we still get the same answer. This is actually just a little bit faster to say who wins and by how many. And most students seem to like that better instead of making, sometimes having to make the exponents negative and then move them top or bottom. So that's up to you on how you do it. I usually go with who wins and by how many because most of my students seem to like that better. Alright, let's look at some actual examples next. Alright, in this example we have 4m cubed over m. So I'm going to go ahead and put an implied 1 in front of there so that we can see what's happening. So we have to divide the numbers as we normally would. 4 divided by 1 is just 4, so we have 4. And then m cubed divided by m, we have 3 on top and then there's an implied 1 exponent there. So 3 on top, 1 on bottom, so the top wins by 2, so m squared. The other way to look at it is subtract the exponents. 3 minus 1 is 2, and that's where that square comes from. So however you look at it, final answer 4m squared on that one. Let's look at another one. Alright, we have another example, 3b squared over 4b cubed. So we divide the numbers as we normally would. 3 divided by 4 is just 3/4. Can't do any more than that. And now we look at the b's, so b squared divided by b cubed. So we can subtract the exponents and say 2 minus 3 is negative 1, or our shortcut that we're using is who wins and by how many. So we have 2 on top and 3 on bottom, so the bottom wins by 1. So there's just b to the first power here. We don't write the first power. And that's it. 3 over 4b for that one. Let's look at another one. Alright, in this next example, 3x to the 4th y cubed all over yx to the 0 power. So just like anything, when we have anything to the 0 power, that's 1. So to make it a little bit easier, we're going to go ahead and just mark that out. So here's what we're dealing with. So on top, we have 3x to the 4th y cubed all divided by y. So the 3x to the 4th is going to stay the same. There's nothing to change that down here in the denominator. But with the y's, we have y cubed over y. So we have y to the 3rd power on top and y to the 1st power on bottom. So the top wins by 2. 3 on top, 1 on bottom, top wins by 2. So y squared ends up being on top, and that's our final answer. Let's look at another one. Alright, in this next example, you'll notice I have it here twice because I'm going to show you two different approaches to solve the same problem. And with most of these exponent problems, especially when they get more complicated, there are often different paths that you can take to get the correct answer. And the main thing is, as long as you get the correct answer, then that's fine. And the path that you take really doesn't matter, and you can find the approach that you like better and just stick with that. So with that said, the first thing I'm going to do is just leave the problem as is and work with it. So I have, for numbers, there's an implied 1 here and there's a 2 down here. So for numbers I have 1 over 2, so I'll leave that there. And then for the x's, we'll do who wins and by how many. So does the top or the bottom win? Well, this is a little more complicated because we have a negative exponent in both cases. So -2 and -3, who wins? You might say the bottom wins by 1, but that's not right. Actually, -2 is 1 larger than -3, right? So the top wins by 1. So we have x to the first power on top. And now the y's are a little easier. Y squared on top, y cubed on bottom. The bottom wins by 1. So we have y to the first power on the bottom. I do not have to have this 1 here since I have something else on top to hold that place. But I could leave it. It doesn't matter. So anyway, we get x to the 2y, x over 2y there. So now I'm going to show you another way to work it. So sometimes students don't like messing with these negative exponents, so they go ahead and rewrite the problem without any negative exponents. So what I can do is I can take this x to the -3 power and move it on top. It becomes x to the +3. Remember, if you have a negative exponent on bottom, you move it to the top, make the exponent positive. Do the same thing with this x to the -2 power on top, move it to the bottom, make its exponent positive. There we go. So that the negative exponents are handled, and now write everything else where it was before. The y squared was on top, stays there. Y cubed was on the bottom, stays there. 2 was on the bottom, stays there. And now approach it with who wins and by how many. So we have an implied 1 on top, 2 on bottom, so that's a 2 on the bottom. I'm not going to write the 1 up here because I know we'll have something else left. Now for the x's, we have x cubed over x squared. Well, the top wins by 1. 3 on top, 2 on bottom. Top wins by x to the first power. Then we have y squared over y cubed. Well, we have y squared on top, y cubed on bottom, so the bottom wins by 1, y to the first power on bottom. So either way, we get x over 2y, and either approach works. We approached them in a little bit different way, but we ended with the same correct answer. All right, let's look at another one. All right, next example here, I've got it down twice here. We're going to approach it just the same way we did that previous problem. I'll work it twice. So, looking at the problem for numbers, we have an implied 1 on top, 3 on bottom. We can't do any more than that. 1/3 is just 1/3. Now, looking at x's, we'll go in alphabetical order. We have x's, y's, and z's. We'll just stick with that. For x's, we just have an x to the 5th on the bottom, nothing on the top to make any changes, so we'll just leave it as x to the 5th. Now for y's, so we have -5 as an exponent on top, -4 as an exponent on the bottom. So if you work with who wins and by how many, you have -4 on bottom, -5 on top. So the bottom actually wins by 1, so it's y to the first power. We won't write the first power, but it's implied to be there. Remember, -4 is 1 larger than -5, so you have to be careful with those negative numbers. And then for z's, we have z to the 4th on top, z squared on bottom, so the top wins by 2. So z squared on top. And if we want, we can go ahead and erase that 1 since we have a z squared on top to hold that top place. All right, so answer there is z squared over 3x to the 5th y. Now let's do the same problem again, only this time we're going to go ahead and handle the negative exponents in the beginning. So we're going to take this y to the -5th on the bottom. We're going to take this y to the -4th on top. So we'll end with y to the +4 on top, z to the 4th. And we'll have 3x to the 5th on the bottom. That didn't change. And now the y to the -5 comes down, make the exponent positive, y to the +5 there. And then we had a z squared on bottom. So now we don't have any more negative exponents, so some students like this better. We have y to the 4th on top, y to the 5th on the bottom, so the bottom wins the y by 1, y to the 1st. We have the 3x to the 5th already on the bottom. We had an implied 1 here, remember, so the 1/3, we can't handle that any differently. So And then the x to the fifth, there were no x's up here to make any changes, so we left that. Now for the z's, z to the fourth, z squared, the top wins the z's by 2, so z squared on top. And you see we got same answer here and here. One of them we handled the negative exponents in the beginning. This first method we just worked with them and moved forward. Alright, that's it for this video on quotient of powers.